Hello, everyone, and welcome. I'm excited to have you here today. Our focus is on optimizing Lakehouse performance in Microsoft Fabric. The subtitle is Strategies for Enhancing Query Speed, Reducing Costs, and Ensuring Scalable Analytics. In this session, we'll explore practical ways to improve performance, cut costs, and scale your analytics effectively within Microsoft Fabric. So let's dive in and discover how to make your Lakehouse solutions more efficient and powerful. Let's take a closer look at some of the key challenges we face when it comes to optimizing Lakehouse performance in Microsoft Fabric. These challenges affect a wide range of roles, from IT professionals managing infrastructure to business leaders relying on quick and reliable analytics. Everyone expects fast insights, but that's not always the case. One major issue is rising cloud costs, which are often driven by inefficient use of resources. When resources aren't optimized, expenses can quickly escalate. Another common pain point is slow query responses, which can delay critical insights and hinder decision-making. Despite following best practices, Microsoft Fabric Lakehouses sometimes encounter frustrating performance issues. These challenges highlight the importance of targeted optimization strategies to ensure everyone gets the performance they need. Let's talk about the reality of slow queries and why they matter. Slow queries are not just minor technical hiccups. They actually have a real impact on your business agility and decision-making processes. When queries take too long, it can erode confidence in your analytics platform, making users doubt the reliability of the data they need to act on. This leads to a poor user experience, with long wait times and stalled meetings, which can seriously hamper productivity. Most of these slowdowns happen because queries are scanning excessive amounts of irrelevant data, or because caching and file management aren't optimized. Even in well-architected lakehouses, you might see lagging power by dashboards or sluggish reports. These performance issues directly affect how quickly and effectively your team can make data-driven decisions. So, addressing these slow queries is crucial to maintaining agility and ensuring your analytics platform supports your business goals. Optimizing query efficiency is absolutely crucial because it helps us strike the right balance between system performance and controlling costs. When queries run slowly, it can really hinder our ability to make timely decisions, which in turn diminishes the value of our data investments. If insights are delayed, it not only affects our agility, but can also lead to higher costs. Stakeholders often question the return on investment when they see slow results and increased expenses. Inefficient queries also waste cloud resources, inflating our budgets unnecessarily and reducing overall efficiency. And let's not forget, slow analytics queries force the system to work harder and longer, which drives up compute costs. So it's clear that the cost of inefficient queries isn't just about slow performance. It impacts our entire ecosystem, from finances to decision-making. This is why optimizing Lakehouse performance in Microsoft Fabric is so important. It's all about making sure we get the most value out of our data while keeping costs in check. Ignoring actual query behavior when partitioning can lead to some pretty significant inefficiencies and performance issues. When we don't align our data layout with how users actually query the data, we risk creating bottlenecks that slow down everything. Effective partitioning is really about understanding the real-world usage and making sure our data is organized in a way that supports those patterns. This is crucial because if we get it wrong, we might not see the immediate impact, but over time, these hidden costs add up. They show up as longer query times and increased cloud expenses, and often we don't notice until our scale grows significantly. Poor partitioning forces our query engines to scan through large amounts of irrelevant data or handle excessive metadata, which severely impacts performance. That's why default patterns, like partitioning by date or region, can sometimes work against us if they don't match how our data is actually used. Understanding these pitfalls is key to optimizing our Lakehouse performance in Microsoft Fabric. When we get partitioning right, we ensure our queries run faster, our costs stay manageable, and the whole system operates more smoothly. When partitioning goes wrong, it can really impact your Lakehouse performance in Microsoft Fabric. One common issue is creating thousands of tiny files, which might sound harmless, but actually causes storage bloat and adds significant coordination overhead. This means more effort is needed to manage all those small files, and it slows down your overall system. As a result, you end up paying more in cloud bills because the storage and processing costs increase. On the other hand, massive scans over large data sets are also problematic. When data isn't partitioned properly, queries have to sift through huge amounts of unorganized data, which slows down query response times and ramps up costs because more resources are consumed. The key takeaway here is about over-partitioning versus under-partitioning. Over-partitioning creates too many small files, causing inefficiency, while under-partitioning results in large, unwieldy datasets that slow things down. Striking the right balance is crucial to optimize performance and control costs. This ties directly into our overall theme of ensuring efficient data management in Lakehouse architectures. Let's talk about choosing the right partition keys to truly optimize your Lakehouse performance in Microsoft Fabric. This step is all about transforming partitioning from a mere default setting into a strategic tool that gives you an advantage. When done thoughtfully, it helps you reduce unnecessary data scans, which means faster query responses and more stable costs. A key part of this process is collaborating closely with your business analysts. By reviewing query logs together, you can identify which columns are most frequently filtered or aggregated. This insight allows you to select partition keys that align with actual usage patterns, rather than just relying on what's convenient from a data model perspective. The main takeaway here is that effective partitioning isn't just about splitting data randomly. It's about making smart choices based on real user behavior. When you base your partitioning strategy on these patterns, you'll see improved performance and cost efficiency. It's a strategic shift that can make a big difference in how your Lakehouse operates. Now, let's look at this real-world example of how a simple change can make a big difference. Here, we're focusing on optimizing Lakehouse performance within Microsoft Fabric. The key idea is that by realigning the partition keys to better match the actual query filters, we saw a significant and measurable improvement in both speed and cost predictability. Specifically, by rebuilding the partitions around the order type, we were able to have the refresh times, which is a huge efficiency gain. Plus, this adjustment helped stabilize query costs, making budgeting more predictable. Initially, most queries were filtered by order type, but the data was partitioned by region. This mismatch caused broad scans across all regions, leading to poor performance. It's a classic example of how inherited partitioning schemes, based on organizational structure rather than query patterns, can hinder performance. So, by realigning those partitions to match how the data is actually queried, we can unlock better performance and cost management. This highlights a fundamental concept. Understanding your query patterns and adjusting your data structure accordingly can lead to dramatic improvements. Let's talk about caching and why it's so crucial for performance. Caching ensures that hot data, or the data that's accessed most frequently, is instantly available when needed. This means faster response times and a smoother experience for users. Properly tuning your cache reduces the need for disk reads, which can slow things down, and it accelerates query execution overall. Microsoft Fabric uses multiple caching layers, specifically the result set cache, the warehouse cache, and the file-level cache. Each of these stores frequently access data in memory, helping to keep your Lakehouse responsive even during peak workloads. While partitioning is useful, it alone can't guarantee fast queries. That's where caching comes in as the next critical lever. By combining both, you can significantly enhance performance. So, moving beyond simple partitioning and embracing effective caching strategies is key to optimizing Lakehouse performance in Microsoft Fabric. Let's talk about why caching often fails in Lakehouses. Even when you enable caching, many systems still experience slowdowns. The main reason is that the default cache management tends to prioritize fairness over the actual importance of the data. What does that mean? Well, it often pushes out the most critical, business-critical tables from memory to make room for less important, rarely used data. This can cause a problem because those hot tables, think of them as the most frequently accessed or vital data, get forced out of memory. When that happens, queries that rely on that data have to fall back to slower disk access, which slows down performance. And the consequences? Wasted memory resources, unpredictable query times, and frustration for users who expect quick results. Plus, it can lead to higher compute costs because the system is working harder to retrieve data from disk instead of memory. So the challenge here is that default cache management isn't always aligned with business priorities. It's a balancing act between fairness and data importance, and often, the current approach leans too much toward fairness. This is a key obstacle we need to address to optimize Lakehouse performance effectively. Now, let's talk about turning caching from just a passive feature into an active performance tool. The idea here is to treat caching as something we actively manage and optimize, rather than just letting it run in the background. One key strategy is regularly reviewing query patterns. By doing this, we can adjust cache priorities accordingly, which helps keep our system's performance stable and predictable over time. Another important aspect is automating cache management. Automated tools can dynamically handle less critical data, freeing us up to focus on more important areas. But for the data that really matters, manual pinning is still very valuable. Pinning tables in memory ensures those tables stay quickly accessible, providing consistent fast performance, especially during peak business hours. Finally, effective cache tuning involves identifying the hottest tables, those most frequently queried during critical times. Prioritizing these ensures that our cache is optimized for the most impactful data, ultimately enhancing the overall performance of our Lakehouse environment in Microsoft Fabric. Let's take a closer look at the real-world impact of cache optimization. By focusing on optimizing the Lakehouse performance within Microsoft Fabric, we've seen some meaningful results. Firstly, with these improvements, resources have been freed up to concentrate on more proactive initiatives. Instead of constantly troubleshooting, they can now work on strategic enhancements that add more value. One of the most significant outcomes has been the elimination of performance complaints. Many of these issues were resolved simply by fine-tuning the cache, leading to a much smoother user experience. And on the cost side, we've achieved a 30% reduction in compute costs. This was made possible by pinning key report tables into memory, which optimized cache usage and improved efficiency. Overall, these cache optimizations not only boost performance, but also enable the IT team to focus on future improvements, reinforcing the broader goal of making our data infrastructure more agile and cost-effective. Let's talk about cache misconceptions and how to manage it effectively. When it comes to optimizing Lakehouse performance in Microsoft Fabric, it's important to remember that cache should remain focused on what matters most. This focus helps us achieve sustained performance gains and keeps costs in check. The key is to prioritize critical data, those datasets that are accessed most frequently or are vital for your operations. Continuous monitoring plays a crucial role here. By keeping an eye on cache usage, we can make informed adjustments based on how the usage patterns evolve over time. It's also essential to understand that Microsoft Fabric's memory is finite and can be costly. So, cache management isn't a one-and-done task. It requires ongoing attention to ensure we're using resources efficiently. Now, a common misconception is that more cache always equals better performance. That's not true. Overcaching irrelevant or rarely accessed data just wastes expensive memory and doesn't speed up the critical queries we need to optimize. In essence, effective cache management is about focusing on what truly matters, continuously monitoring, and adjusting wisely to get the best performance without overspending on resources. Understanding file-level bottlenecks is crucial because they can quietly undermine all our other optimization efforts. These hidden inefficiencies often go unnoticed, but they have a real impact on performance. When we have too many small files, it leads to increased read latency, meaning it takes longer to access the data. It also causes metadata overhead, which adds extra processing time, and it can drive up compute costs because more resources are needed to manage all those files. This proliferation of tiny files forces the query engine to do a lot more work. Instead of scanning a manageable number of large files, it has to coordinate across thousands of small ones, which adds complexity and slows down the overall process. This is especially true in Delta Lake tables, where incremental updates and batch operations tend to create many small files over time. Even when we try to optimize with partitioning and caching, file fragmentation and sprawl can still cause performance issues. The files become scattered, and the query engine has to work harder to piece everything together. So, understanding and addressing file-level inefficiencies is key to maintaining a high-performance Lakehouse environment. Let's talk about the Delta Lake File Challenge. As many of you know, Delta Lake uses an append-only model, which means that with each update, it adds new Parquet files instead of replacing the old ones. Over time, this can cause a significant increase in the number of files within a table. What was once a manageable number can grow into thousands of small files. This growth can turn what used to be quick, efficient scans into slow, resource-intensive operations. Essentially, the more files there are, the harder it becomes for the system to quickly find and retrieve the data it needs. This file sprawl is a common culprit behind unexpected query slowdowns and can also lead to rising cloud costs, particularly in mature Lakehouse environments where incremental loads happen frequently. So, understanding and managing this challenge is key to optimizing the performance of your Lakehouse on Microsoft Fabric and ensuring cost efficiency. Now, let's talk about the power of file compaction and how it can significantly boost Lakehouse performance within Microsoft Fabric. One of the key benefits is streamlined metadata management. When we use compaction, it simplifies the way metadata is handled and makes backup processes much more efficient. This means less time spent managing data and more time focusing on insights. Additionally, compaction helps lower both compute and storage costs. By reducing the amount of data that needs to be processed and stored, we can achieve considerable savings. And perhaps most importantly, it dramatically reduces read latency. This is crucial because faster data access means quicker insights and more responsive applications. In fact, file compaction can cut read latency by as much as 80%, which is a game changer for performance. Overall, this process aligns perfectly with our goal of creating a more efficient, cost-effective, and high-performing Lakehouse environment. Now, let's talk about automating compaction effectively to maintain Lakehouse performance. Automated compaction plays a crucial role here because it helps keep things running smoothly without requiring a lot of manual effort. This means that once set up, the system handles the regular maintenance, ensuring consistent operation and optimal performance. Next, optimizing compute cycles is essential. By leveraging data-driven automation, we can save valuable compute resources. This approach reduces redundant work, which not only improves efficiency, but also lowers costs. When it comes to responding to fragmentation, using data-driven triggers allows the system to react quickly whenever fragmentation starts to build up. This timely response helps ensure that compaction happens when needed, preventing performance degradation without the need for manual oversight. Finally, effective data-driven compaction triggers should be based on real data conditions, like file size and growth patterns. This targeted approach prevents unnecessary compaction runs, especially when file sprawl is minimal, making the process more efficient and avoiding over-optimization. Overall, these strategies help us keep the Lakehouse performant, scalable, and efficient, aligning perfectly with our goal of seamless data management. Let's take a closer look at the impact of automated compaction on refresh times. Initially, without any hardware changes, we managed to reduce the refresh time to under 2 minutes. That's a significant improvement, especially considering the scale of data we're working with. However, as the Delta Lake table grew in size, we saw the refresh time increase to over 10 minutes. This increase highlights how data growth can impact performance if we don't optimize continuously. Now, for the finance team using Power BI, their initial refresh times were just about 2 minutes. That quick turnaround allowed them to stay agile with their reporting. The key takeaway here is how implementing automated compaction can dramatically improve performance, keeping refresh times fast and consistent, even as data volume increases. This aligns perfectly with our overall goal of creating a highly responsive and scalable Lakehouse environment. Let's talk about how a holistic approach can really transform Lakehouse performance in Microsoft Fabric. When we combine these strategies, like optimizing partitions, targeted caching, and file compaction, they work together to deliver better results. Optimized partitions mean that when you run a query, the system scans only the relevant data, which speeds things up significantly. Targeted caching helps by keeping hot data readily accessible, so you don't have to fetch it repeatedly from storage. And file compaction keeps your file structures lean, reducing overhead and making data access more efficient. The key point here is that these strategies reinforce each other. When aligned properly, they don't just add up, they multiply the performance gains. Instead of treating partitioning, caching, and compaction as separate fixes, think of them as interconnected levers. By integrating these three elements, we unlock the greatest performance improvements, leading to faster queries, more predictable costs, and ultimately, happier users. This holistic approach is essential for truly optimizing Lakehouse performance in Microsoft Fabric. Let's talk about diagnosing your Lakehouse performance issues. One of the key tools here is file metadata reports. They are really useful for detecting file sprawl, which can cause inefficiencies. By systematically diagnosing these issues, you can make sure your optimization efforts are focused on the areas that will have the highest impact. Next, evaluating file health is crucial. Cache monitoring dashboards play a vital role here. They help us identify cache inefficiencies. If there's a slowdown, these tools can tell us whether it's related to cache performance or something else. Monitoring cache usage is another important step. To find bottlenecks, you need to analyze query patterns, cache usage, and file health together. Tools like query logs are especially helpful. They enable us to pinpoint whether slowdowns are caused by partition misalignment or other issues. In summary, by examining these different areas, file metadata, cache health, and query behaviors, you can systematically diagnose and improve your Lakehouse's performance. This approach ensures you're addressing the real root causes and optimizing effectively across your system. Now, let's talk about how to sustain those performance gains as your Lakehouse scales and evolves. It's crucial to regularly adjust your optimizations to meet the changing needs of your workload and data environment. This way, you ensure that your system remains efficient and responsive over time. Next, it's important to communicate these improvements clearly to your stakeholders. Building confidence through transparent updates helps everyone understand the value of the changes and keeps everyone aligned on goals. To support continuous performance, you should measure key metrics like query times and cost after each optimization step. Ongoing monitoring is essential to verify that your efforts are paying off and to catch any issues early. When implementing changes, do so incrementally. Small, controlled adjustments allow you to evaluate their impact without risking larger disruptions. After each step, again, measure query times and costs to track progress. Before diving into fixes, start by prioritizing based on potential impact and effort required. Review your partition keys against query filters to optimize data retrieval. Tuning caching for critical datasets can provide immediate performance boosts. And don't forget to assess file fragmentation levels, which can significantly slow down data access. By focusing on these areas systematically, you ensure that your optimization efforts are targeted, effective, and sustainable as your Lakehouse grows. Now, let's talk about how we communicate these improvements to our stakeholders. The key is to frame the conversation around enabling agile, on-demand insights that empower our leaders to act quickly and confidently. When we share these updates, it's important to highlight metrics like percentage reductions in query latency and cloud spend, because these figures help build trust and confidence in the data team's efforts. Using before and after scenarios is also very effective. It allows us to illustrate the tangible improvements we've made, making technical changes more understandable by focusing on the business impact. For example, showing how these optimizations lead to faster dashboard refreshes or shorter query times helps stakeholders see the direct benefits. Cost savings are another critical point. By emphasizing how optimized partitioning, caching, and compaction reduce both cloud compute and storage expenses, we underline the value of these technical improvements. Finally, highlighting tangible outcomes such as quicker decision-making and more responsive data insights makes the benefits clear. Faster access to insights means our teams can act more swiftly, which is ultimately the goal of these performance enhancements. Let's talk about how to avoid common pitfalls as we move forward with optimizing our Lakehouse performance in Microsoft Fabric. First, it's really important to encourage collaboration between data engineers, analysts, and business users. When these groups work together, we can ensure that performance tuning reflects real-world workloads, making our system more efficient and responsive. Next, we should conduct routine health checks on our Lakehouse environment. Regular monitoring helps us catch emerging bottlenecks early, before they start impacting our users. Think of it as a proactive approach to maintaining a smooth and reliable system. Another key point is establishing dynamic file compaction strategies. Instead of sticking to fixed schedules, we need to base our strategies on data growth and file counts. This prevents file sprawl, which can slow down performance and complicate management. Additionally, during peak hours, it's best to manually pin critical tables. This ensures that the most important data is readily available, enhancing overall performance. Monitoring our cache usage actively is also crucial. By doing so, we can prevent performance roller coasters and keep things running smoothly. Finally, it's vital to regularly review query patterns and update our partition keys. As our business questions evolve, so should our data organization. Avoid default or outdated setups to maintain optimal performance and ensure our system adapts to our changing needs. All these steps help us stay ahead and keep our Lakehouse environment performing at its best. Let's take a look at some of the future trends in Lakehouse performance, specifically within Microsoft Fabric. One key area we're focusing on is seamless scalability. This means enabling Lakehouses to handle increasing data volumes efficiently without compromising on speed or budget. It's about making sure our systems grow with your needs smoothly and cost-effectively. Another exciting development is the integration of real-time monitoring dashboards. These tools will give us actionable insights into query performance and cost drivers, helping us identify bottlenecks and optimize resource usage on the fly. This real-time visibility is crucial for maintaining peak performance. We're also working on improving delta, like compaction algorithms. The goal here is to dynamically balance performance gains with resource efficiency, ensuring your data lake remains optimized without unnecessary overhead. AI-driven partitioning tools are another innovation on our roadmap. These leverage artificial intelligence to recommend the best partition keys based on query telemetry and business context, making data organization smarter and more aligned with actual usage patterns. Finally, Microsoft Fabric is enhancing automation in caching. This means better prediction and adaptation to shifting workload patterns, which reduces manual tuning and helps maintain high performance with less effort. All these trends are about making Lakehouses more scalable, smarter, and easier to manage, aligning perfectly with our goal of empowering you to get the most out of your data. Let's review some key takeaways for optimizing performance in our Lakehouse environment on Microsoft Fabric. First, regularly compact Delta Lake files based on data conditions. This is crucial because it helps prevent file sprawl, which can slow down your queries and increase costs. By maintaining smaller, well-organized files, you improve read latency and also lower your cloud charges. Next, actively managing cache is essential, especially during critical periods of data processing. Keeping hot data in memory means faster query responses and more stable budgets, as it reduces the need for repeated data fetches from storage. Finally, choosing the right partition keys is more important than ever. Instead of selecting partitioning schemes out of convenience, base your decisions on actual query filters. This way, you minimize unnecessary data scans, which directly reduces cost and enhances efficiency. All these strategies work together to ensure your lakehouse performs at its best, delivering faster insights while keeping costs under control. Now, let's open the floor for questions and discussion. I want to hear about real-world scenarios where tuning performance has actually made a difference in business outcomes. Sharing these experiences can help us all learn and improve. As we explore solutions and best practices together, remember that our goal is to ensure everyone gets the most value from their lakehouse investments. One key question to consider is how you balance automation with manual tuning in your environment. Do you rely more on automated tools, or do you prefer hands-on adjustments? Understanding this balance is crucial for optimizing performance effectively. Another important point is the optimization strategies you've found most effective, or, conversely, the ones you've struggled to implement. Sharing these insights can help us all identify what works and what challenges to anticipate. Finally, I'd like to know what specific challenges you've faced with Lakehouse performance in Microsoft Fabric. Recognizing these hurdles allows us to address them directly and improve our overall approach. So, let's dive into your questions and experiences. Your insights are invaluable for everyone here. Let's wrap up with some key takeaways and next steps. Remember, small changes can lead to big results, so don't underestimate the power of incremental improvements. Empower your team to deliver faster insights and make smarter decisions around cloud spend. Next, focus on continuous improvement. Dive into the Microsoft Fabric documentation, engage with community forums, and listen to expert podcasts like the M365 Show. These resources are great for expanding your knowledge and staying updated. When it comes to optimizing performance, set up data-driven compaction triggers to keep your Delta Lake files optimized. This helps maintain efficiency as your data grows. Also, identify the tables with the highest usage and consider applying manual cache pinning during peak times. Pinning hot tables can significantly improve query performance when it matters most. Finally, review your partitioning strategy regularly. Make sure it aligns with your actual query patterns. This way, you're optimizing resource usage and improving overall performance. Remember, by focusing on these incremental steps, you can ensure your lakehouse environment remains efficient, scalable, and ready for future growth.